Let's now look at an example where we want to determine the accuracy of a linear approximation. This example is split up into two parts. For the first part, we are going to find the linear approximation of the function f of x is equal to the square root of x plus 3 at the point a is equal to 1. When we find a linear approximation, we are just finding a linearization. So we're going to start by writing down the formula for a linearization. That is L of x is equal to f of a plus f prime at a times x minus a. Let's go ahead and substitute in that a is equal to 1. So L of x is equal to f at 1 plus f prime at 1 times x minus 1. We need to find f of 1 and f prime at 1. I'm going to start by writing down f of x. F of x is the square root of x plus 3. And because we have to take the derivative, I'm going to write this also as x plus 3 to the 1/2. Now we can find f at 1. Just substituting in x as 1, we get the square root of 4, which is 2. Let's highlight that so we can find it later. Now we need f prime at 1, so we first need to find f prime at x. This is 1/2 x plus 3 to the minus 1/2. We can write this as 1 divided by 2 times the square root of x plus 3. Now we have to find f prime at 1. So x is just going to be 1. So we have 1 all over 2 square root of 4. So that is just 1 over 4. And let's highlight that. Now we can write down L of x. L of x is f of 1, which is 2, plus f prime at 1, which is 1/4, times x minus 1. And that's our linear approximation. Now let's look at the second part. We are going to determine the values of x for which this linear approximation is accurate to within 0.1. A linear approximation is accurate to within epsilon. We use epsilon to indicate when we have something relatively small. So our linear approximation is accurate to within epsilon when the absolute error is less than epsilon. The absolute error is notated as capital E of x, and it's just the absolute value of f of x minus L of x. So we say that this absolute value is less than epsilon, and then to make things easier, we get rid of the absolute value, and we put epsilon on either side, and then we know that our function is going to be between L of x minus epsilon and L of x plus epsilon. Let's now see how this works for our example. We want the absolute value of f of x minus L of x, that is the error, to be less than 0.1. This means that minus 0.1 is less than f of x minus L of x, is less than 0.1, and then L of x minus 0.1 is on the left. In the middle, we have f of x, and then on the right, we have L of x plus 0.1. Now we're going to substitute in for L of x and f of x. L of x was 2 plus 1/4 x minus 1, and then we subtract 0.1. And then our f of x is the square root of x plus 3. And then on the right, we again have L of x, 2 plus 1/4 x minus 1, but now we add 0.1. This equation is really hard to solve algebraically, and we might not even be able to do it. So what is done in practice is that you graph all three of these pieces. The graph of the first piece is just a linearization, so it is a straight line, and I have that straight line drawn down here in green. And then the right-hand side is also a linearization, so that is a straight line, and I have that drawn in purple. And then the function that we're approximating, I have drawn in blue. The function is only going to intersect one of these straight lines. In our case, our function, the square root of x plus 3, is concave down, so it's going to intersect the green line. Let me go ahead and make this bigger so that you can see that. I graphed this on Desmos. It's a really great free graphing tool if you want to use it when you do these types of problems. And I found that our linearization intersects our function here and here. So that tells us that our linearization is going to be accurate to within 0.1 when x is between minus 1.13 and 3.93. Let me go ahead and let's write that down. So our answer is going to be minus 1.13 is less than x is less than 3.93. Our linearization then will be accurate to within 0.1 when x is between these numbers.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.